something you remember about slope? Then I know I don't have to teach it. Okay. Okay, I'll take both those things. All right, so I heard y equals mx plus b. I heard y2 minus y1 over x2 minus x1. How are those two things related?
The bottom equation for slope.
The bottom equation is worked out so that you figure out what to plug in for what letter? M. Okay, so those two things are related because m is equal to that. Anything else you remember about slope? Say it again. Oh, wow. That has been. Go ahead. Nobody in first period remembered that. But you remembered the name. That's even better than everybody else. Okay, all right. Yep. So he's talking about, all right, so this one is called slope intercept form. And Aaron is talking about something called point slope. All right, but he knows it's there, like it's somewhere in his memory bank someplace, but not pulling it out right now. And that's totally fine because that's more than anybody else remembered. So maybe it'll come to you. All right, anything else you remember about slope? Rise? Okay. All right, so that's this one. Rise is the value of the top. Run is the value of the bottom. Okay, so last chance. Anybody want to try for point slope form?
If y equals slope, and then it's like thing the parentheses, right? With x minus the x of the equation, but it's like opposite. Minus is opposite, and then plus the y.
Yeah, usually we'll put that over here. But you were saying plus would be on the other end. That's fine. Okay, great. Fantastic. Okay, that is all you need to know for the lesson today. You guys came up with everything. Now we just have to practice it. Okay, now we need to practice it. Okay, so we need some instructions. The very first thing to come out of anybody's mouth was Katie's, and she said y equals mx plus b. All right, it is the most, one of the most familiar equations in math. The problem is that it's not the thing that you start with. Okay, and a lot of people get tripped up because they think they're supposed to start with y equals mx plus b, and it's not. It's what you're supposed to end up with at the end. That's the end, right? You want to start with point slope. So in your notes, make like big stars, okay, or something. Start here. Okay, that is where you're going to start your problems. You'll finish with y equals mx plus b, but we're going to start there. Okay. Let me just draw a little dividing line here. All right, so let's practice what we're going to do. All right, so everything we need to know is above that line. So let's just practice with it. All right, here we go. Complete the following. M equals -3. -2, +3 is the first point. And 4y is the second point. Complete the following. In other words, figure out what y is to complete that problem. Everything we need to know is above that line. Okay, so of the stuff that's above the line, what will I be using to practice with this problem? Okay, which of those three things? Name it. Say it again. Yeah, okay, I want to use the rise over run. All right, so we want to name it. Yep, we're going to use our rise over run, so we're going to drop all the available numbers into rise over run. So negative 3 is the m value. And we want to put these numbers in order, y2 minus y1. So that would be y minus 3 over, and then the x2 minus the x1, so 4 minus negative 2. So you got a double negative going on in the denominator. So I end up with negative 3 equals y minus 3 over the denominator 6. Here's where the magic happens. Because what should I put under the negative 3? A 1, which is going to give me the chance to cross multiply. So cross multiply to the right, we get y minus 3. Cross multiply to the left, we get negative 18. Add 3 to both sides. The answer to y is negative 15. All right, so everything we needed to know you guys came up with out of your recall. We just have to practice with it. So complete the following. We just did. Okay, let's do another example. So same thing. Complete the following. Find the missing stuff. 3x plus 4y should always equal 26. What's missing in the combination of x2? And what's missing in the combination 10y? These are actually two separate questions. It's like part A is here, and this is part B. All right, so you should be able to complete the following. You should be able to find the missing values, just using the fact that 3x plus 4y should always equal 26. So for part A, it's going to be 3x plus 4 times what number? In part A, what do we know that y is? Y is 2. So for that problem, it will be 3x plus 4 times 2 is equal to 26. Because it should always be equal to 26. That means 3x plus 8 should be equal to 26. That means if I subtract 8 from both sides, 3x should be equal to 18. And it means x should be 6 in the first place. So 3x plus 4y should always be equal to 26. Now you can do the same thing with part B, using 10 and y. Okay, can somebody try that and get it set up for me? Okay, Harrison, 3 times 10 plus 4y, and that should also be equal to 26, because it always should be. So 3 times 10 is 30, plus 4y is 26. I'll subtract 30 from both sides. That will give me 4y equals negative 4 when you subtract, which means y had to be equal to negative 1, and that's the completed value. Okay, any questions so far? So that's using the different values of point and slope and coordinates. Okay, let's try another one. Write a linear equation for negative 3, negative 8, and for 4, negative 1. Okay, now I had you put stars and stuff around start here. Every time you do a linear equation, you're going to start with the point slope equation. So let's get that focused on here. We want to start here. Y minus y1 equals mx minus x1. Okay, and that is called point slope. It's giving you the name gives you the directions. Point. Put the point into the equation. Okay, well, what point? The x1, y1 point. Okay, that's the name of it, is also the instructions of what to do. So we're going to put the x1, y1, which is -3, -8, and we're going to drop that into the equation. So y1 is -8, so it'll be y minus -8, which is a double negative, equals m. And then x1 is -3, so it'll be x minus -3, which again is a double negative. All right, so I did the point part. The next part of the name is the next part of the instructions, which is slope. So now you want to put the slope in, but what's the inherent problem in this? I don't know what the slope is yet. Okay, we're going to have to do a little side job here and figure out the slope, rise over run, so that we can do the next step. So you kind of work yourself a little side job, y2 minus y1 over x2 minus x1. This is going to be our little side job over here. And we're going to figure out what the rise over run is so we can plug it in. y2 was y2 was -1 minus y1, which was -8, so that's +8. x2 was 4 minus -3, so +3. So I end up with a numerator that's -7 and a denominator that's +7. So the value of the rise over run is -1. So that's my side job. Once I got that done, I can get back to my main job. So my main job is now put the slope in there. So I'm going to have y plus 8 equals -1, which turned out to be the slope, and then x plus 3. The last part of your main job is to make this look like y equals mx plus b. Okay, you want to make the parentheses disappear, and you want to have it be in the order y equals mx plus b. So having that all worked out. So how to make these parentheses disappear? Distributing. Okay, let's get that going. So y plus 8 equals -1x minus 3. And then I simply subtract the 8 from both sides. So I have -1x minus 11. And now it's in the format where I stop here. So when you get into slope-intercept form, then you're complete. You have written a linear equation starting with the right position and ending up with y equals mx plus b. All right, so y equals mx plus b, and we stop here. What? Yeah. Well, it should be a review, right? Yeah, Kate.
Like on a quiz or test,
Mhm.
if you had the -1x, would it be okay if it's just -x?
Sure, sure. Okay, so she's asking, is it necessary to write the 1 there? It could just be -x. Yeah, that's totally fine. Okay, there was one thing you did not come up with when I asked you to brainstorm up here. And that's fine, because I don't even know how much you talk about it in Algebra 2. But I'm going to have you, put like a line here. And there is one more form. We've got point-slope form, we have slope-intercept form. There's a third form, which is ax plus by equals c. And that's the third form. It's called the standard form. And there's a reason that they use capitals unlike the other equations. Okay, the other equations all use lowercase. So why does this use uppercase instead? And it's intentional. There's a purpose for it. So the reason we use uppercases for standard form is these 3 things, A, B, and C, can't be fractions or decimals. So that's the difference between a capital letter and a lowercase letter. Like a lowercase letter can be a fraction, but an uppercase letter can't be. So let's practice putting something in standard form. The beginning is all the same. Start here. That will never change. That will always be the same. The ending of standard form will be different. All right, so the instructions will be similar. Write a linear equation, but it'll say something like this. Write a linear standard equation. So that's how you'll know that you got to stop with a standard equation. And write a linear standard equation for, and let's this time do negative 4.5 with the other 0.43. The start here instructions are still the same. We start with y minus y1 equals mx minus x1. So that will not change. It's going to be point first, slope second. So again, just follow the name of the equation to know the order that you do it in. So we're going to drop the point in first. That would be x1 and y1. So that would be y minus 5 equals m times x minus a negative 4. So double negative would be positive. Then comes your side job. So we need to work on our rise over run to figure out what the slope value is going to be. So my side job would be 3 minus 5. That's y2 minus y1 over 4 minus negative 4, double negative. So I end up with negative 2 over positive 8, which is the fraction 1/4. And so I can go back to my main job and put that 1/4 in. Y minus 5 equals negative 1/4 x plus 4. Next step is to make the parentheses disappear. I do that with distributing. Y minus 5 equals negative 1/4 distributed to x, and negative 1/4 distributed to 4, which is minus 1. All right, now I need to work on finishing this off in standard form. So just to review, standard form starts out with a capital A in front of x. I don't have a capital A in front of x right now. My x is negative and it's over there, so I needed to move that negative 1/4 over to the other side. So I'm going to add 1/4 to both sides, so 1/4 is in the front. And then I have y. And I also need to make the negative 5 disappear. So I'm going to move that to the other side. I'll have 4. Okay, did you follow what I did? I just did two things at the same time. I added 1/4 x to both sides. I'll write that in yellow. And I added 5 to both sides. So it's almost in ax plus by equals c. It's almost there, except it's not capital yet. Capital says no fractions. I've got a fraction of a 1/4. How do I get rid of a 1/4 so it's not a fraction anymore? Multiply. Multiply by what number? 4. Everything by 4. Not just the front number, but all of it. So multiply this by 4, and this by 4, and this by 4. So my final stop here equation is 1x plus 4y equals 16. That is ax capital plus by capital equals c. I've got all positive all numbers, no fractions. It's in the right order, and I stop here. So the directions, the process is practically identical until you get to the very end, where you just have to watch, am I y equals mx plus b form or standard form? Okay, I got one more for you, and then we are done for the day. Okay, last thing. All right, I want to tell you a little bit about the United States. A little data for you. Back before you were born, the year 1990, the U.S. as a whole country spent $3.8 trillion on personal, pleasure things, spending. Okay, 1995, got even worse. We spent $5.0 trillion on spending. In the year 2000, the year some of you were born, we spent $6.8 trillion on spending. And the year 2005, this is not the U.S. government, these are the U.S. people. All right, this is not the government. Okay, this is the people of how much we are spending on ourselves. Okay, so if this trend would continue, how much are we going to spend, 2020, in the year you graduate? Okay, so what you need to do is you need to, exactly the same thing we've done, is write a linear equation. So you're going to start with y minus y1 equals mx minus x1. That's point, slope. Okay, well, what point? Well, x1 and y1, the first ones. So the x is always the year, x is always time. If you're ever wondering, x is always time. And so the 3.8 would be the y1. So we'll start with that. So y minus 3.8 equals m x minus 1990. Now we come to the slope. We're going to do a side job on here. Now this is where you kind of have your choice. Do you want to do it with 1995 and 5? Do you want to do it with 2000 and 6.8? Do you want to do it with 2005 and 8.8? What do you want to use as your other part of your rise or run? You need to choose one. The book will tell you what to pick. Okay, which one to use. All right, so I'm going to tell you right now, I'll pick for you. We're going to use the year 2000 as our other one. So our side job for slope is to use 1990 and 3.8 as our x1, y1. And we're going to use 2000 and 6.8 as our other comparison. We're going to do a 10-year gap. Okay, the reason I'm choosing that is because I want to predict a 10-year gap. I want to predict 2020. So I would kind of want to count by tens. But the book will tell you, okay, use these two. All right, so we're going to do our side job. So that would be 6.8 minus 3.8 over 2000 minus 1990. So 6.8 over 3.8 works out nicely. It's just 3. And 2000 and 1990 works out nicely. It's 10. So now I know my slope. So y is 3.8, or y minus 3.8 equals 3/10 of x minus 1990. Now I want to get rid of the parentheses, make them disappear by doing your distributing. So y minus 3.8 equals 3/10 of x minus, let's put my calculator away, $597. And the form I want, if it doesn't say standard, we want y equals mx plus b. So we're going to add 3.8 to both sides. So I'll have y equals 3 over 10 x minus 593.2. If I add 3.8 to that. Now I can predict the year 2020 from this. Okay, how much spending will we predict that the United States will have next year? Okay, well, what do x's stand for? What did the row of x's stand for? The year. And the row of y's? The spending. Okay, so if I want to know the year 2020, where do I put it? For x. All right, so let's predict 3/10 times the year 2020 minus 593.2. So we, in our expertise, are going to predict the U.S. to spend $12.8 trillion on personal spending next year. So once you have data, you can use that data to reasonably predict the future based on assuming that we don't have a recession, or we don't have something like stock market crash like they had in the the start of the Depression, assuming all things stayed the same, that there's no major world war or terrorist act or anything like that, assuming things mostly stay the same, and that is what we would predict. So that's the power of math, that it actually, can do something.